All right, we are here with video 14E. We're going to continue modeling the sample proportion and look at a second example. So, from the 2013 Mother Jones magazine reported that 45% of homes in the U.S. contained guns. We'd like to run an investigation in Cecil County to see if there's evidence that we differ substantially from this national figure. So we're going to design a study to unbiasedly sample 400 homes in the county, and we will determine whether or not the homes selected have guns. So let's get to this. The first thing we need to do is check our conditions. So recall there were 4 conditions, and if those 4 conditions hold, then we'll be able to model the sample proportion. So let's go through those. The first one is that your variable has to be categorical. So we're going to go to all these homes, find out you have a gun, yes, you don't have a gun, so you're a no. Yes, no, as to whether you have a gun, that would be categorical. So guns is a yes or a no. Oops, no. That's a categorical variable. So first condition's met. Second condition, we need a random sample, or at least one that doesn't contain bias, and it does say that we're going to just design our study to unbiasedly sample 400 homes in the county. So this one checks out too. So the first 2 conditions hold. The next condition was that your sample size has to be less than 10% of the population. Our sample size, we're sampling 400 homes in Cecil County. That would certainly be less than 10% of all homes in Cecil County. That condition's met. And then there was a last condition that said, this sort of success failure condition, we need to be expecting at least 10 households that would contain a gun and at least 10 households that would not contain a gun. And so out of 400 homes, if the national figure is 45% of them contain guns, then we would expect 400 times 45% or 180 homes to have a gun, and then the remaining 220 would not. Both of those clearly exceed 10. So we expect 400 times 45%, 180 homes to have guns. And out of 400 homes, if 180 of them have a gun, then the other 220 homes will not. And the big thing here is that both of these are greater than 10. So all 4 of our conditions are met, so we'll be able to model the sample proportion using the normal model. So let's go on and see what we need to do next. Pause if you need to so you can copy down all the conditions. All right, B. Determine the mean and the standard deviation of the normal model that we'll use for this problem. To use the normal model, those are the 2 things we need, the mean and the standard deviation. All right, so for the mean, recall that for now we're going to assume that the percentage of homes in the county that have a gun is what is reported from that Mother Jones magazine is 45%. So we'll assume for now that P is 0.45 in Cecil County. And making that assumption then, the mean of the sample proportion is the same as the assumed population proportion, which here is going to be that 0.45. So we know where the normal model will be centered. And then the standard deviation, recall, was the square root of p times 1 minus p divided by your sample size. So we'll fill in our values, 0.45, 1 minus 0.45, and we were sampling 400 homes. So plug that in your calculator. I'll round this to say 3 decimal places. We get that the standard deviation is about 0.025. So about 2.5% there. The mean and the standard deviation, now we have our parameters that we need to use the normal model. So next thing is probably going to be to draw one of those. So if we move on to C, draw and label the normal model. So we're going to have it centered here, and then our standard deviation gives us an idea about the spread. So let's draw a big normal model. This will be centered here at the mean. And then recall that 68, 95, 99.7% rule if we go out 1 standard deviation on either side here. If I take 0.45 and I add 0.025, I'm at 0.475. And if I subtract 0.25, I'm at 0.425. And we ought to get about 68% of the time sample proportions that fall within 1 standard deviation of the mean. We'll do the same thing. We'll go out 2 and 3. So if I go out 2 standard deviations, again move another 0.025. I end up here at 0.5, 50%. Down here I'll end up at 0.40, 40%. And 95% of the time, we can expect sample proportions in that range. And then one more, go out 3. Oops, 0. And almost all the time, we'll end up with sample proportions that fall within 3 standard deviations of the mean. One thing to note, this model is based on the assumption that the population proportion was 0.45. So this is our model for sample proportions based on the assumption that P is 0.45. Obviously, if P differs from that, then this is going to be different. All right, so that's what our model looks like. Now we're going to imagine if we collect our data and see what might happen here. Should draw my picture lower so I can still see it here. But you've got this in your notes. I'm going to let you read this for a second. So now imagine we're going to collect our data. What values of the sample proportion will lead you to conclude that Cecil County differs from the rest of the nation with respect to gun ownership? So just for a second while I have the picture up here. Most of the time, these sample proportion values are going to fall within 2 standard deviations of the mean, right? 95% of the time. Once you move beyond 2 standard deviations from the mean, these get to be unusual. Once you move beyond 3, those values get to be very rare. So most of the time, we ought to be, within this range here. So keep that in mind, and now I'll erase this and we'll write up the answer to D. Just visually wanted you to see that one more time. So again, we collect our data. What values of the sample proportion will lead you to conclude that Cecil County differs from the rest of the nation? If we were within between 40% and 50%, that didn't seem very unusual. If we're beyond those extremes, that would seem to indicate that Cecil County is probably different than the national average. So let's write some of this out. If p hat were to be bigger than 2 standard deviations above the mean, that would be unusual. This was out at 50%. So this is 2 standard deviations that we're moving. So if p hat were to exceed 50%, we collect data from the county. Our sample proportion is bigger than 50%. That seems to indicate perhaps the national average is not true in the county. On the other hand, same thing's true if our p hat value were to be smaller than 2 standard deviations below the mean. So if p hat is below or is less than, this time we'll just go down 2 standard deviations. If we were to get a sample proportion anywhere between 40 and 50%, seems like Cecil County is probably right in line with what's happening nationwide. Again, if in Cecil County, if our sample proportion was greater than 50% or smaller than 40%, that would seem to indicate that gun ownership in the county probably differs from what's going on nationwide. So if this was the case, we'll stick with if we're in those extremes. Just write a concluding sentence here. We'd have evidence that Cecil County differs from the rest of the United States as far as gun ownership goes. So if these were true, as far as gun ownership goes. If you wanted to add to this, I've sort of run out of room, but if you wanted to add to this, if we had sample proportion values, again, between 40% and 50%, that's pretty common that that's going to happen. Then we don't have any evidence that Cecil County differs from the rest of the country. And I believe that that's it for this one. Thanks.